Okay, today we're going to talk about H9D.2, Determinant, Inverse Matrix, and Solving Matrices. So at this point you should have already done D.1, which is explained in with Revision Village. This first link here, if you go to Revision Village Introduction to Matrices, if you go start at minute 740, he shows you how to calculate the determinant and a few other things. The identity matrix is something that we keep coming back to. And then on this other Revision Village link, solving simultaneous equations using matrices, this is a very important lesson which we're going to be applying in a few minutes. Okay, so the first part here is just a bunch of stuff to read, but this is important what they show right here in this example, these two examples. What they show is that if I've got two systems of equation, 10x minus 5y equals 35, minus 3x plus 7y equals 23. In Algebra 1 or Algebra 2, you would have used substitution or elimination to solve this, or graphing even. But instead, we can solve this using matrices. So these leading coefficients I can write as a matrix. And then they both start off with x, so we're going to put an x here, and they both have a y here, so I put y here. And then we've got our constants matrix, which, let's pick a different color, not this marker, this one here. So, and that's our constant matrix. Anyways, we can write a system of equation in a matrix and solve it using our calculator in a much, much easier way. So, so what we learned here in this example was that from Revision Village was that if I've got my matrix written like this, which I just showed you in that first example on that first page, I can solve for these variables using finding the inverse of this matrix and times our constant matrix. Okay, so this first matrix with the coefficients, that's our matrix of coefficients. This is our matrix of unknowns. This is our matrix of constants. So, back to the handout I'm explaining. So, to find the inverse, from the previous assignment, the last question, we learned that to find the inverse matrix, you can take your matrix of coefficients and switch those values there, and then these values here, you keep them in the same spot, but you're going to make them negative, and then you multiply this matrix of coefficient times the determinant, and this is going to give you the inverse matrix if you're calculating it by hand. So let's do this example together here. So the first thing I did is we want to find the inverse matrix. So to find the inverse matrix, we multiply, we're following this formula right here, A times D minus B times C. So the determinant is going to be 1 times negative 4 minus 3 times negative 2. Okay, so 1 times negative 4 gives me negative 4. 3 times negative 2 is negative 6. And then because it's minus, it becomes plus. So my determinant is 2. And if I'm applying this relationship, then I'm going to get 1 over the determinant times our matrix that's been switched around. So the D and the A switch around, the negative 4 and the 1. And the 3 and the negative 2, those change signs. And then I multiply the half times each of these, and we get our inverse matrix. Now, for the most part, we're going to be using the calculator to find our inverse matrix, but I think it's important for you to see how it's done by hand. Okay, so this next one, whenever you see this little picture, that means use a calculator. Okay, so let's put in this matrix into the calculator. So I'm going to hit second x to the negative 1. Let's do this so you can see all the... Okay, so to get the matrix mode, I press second, and then this x to the negative 1, which in blue it says matrix, and I'm going to edit the first matrix. So I'm going to arrow over to edit. I'm going to hit enter, and we've got a 3 by 3 matrix. So I'm going to hit 3, enter, 3, enter, and now it shows a 3 by 3 matrix, and I'm going to put in all these numbers: 4, negative 3, negative 2, 2, 2, 3, 6, 1, negative 1. Okay, so I've entered in my matrix. So to find my inverse matrix, okay, second mode to quit, to get out of there. So second x to the negative 1 gets me my matrix, and I'm going to hit enter, and then it's listed my matrix, and then I'm going to hit this x to the negative 1, so because we're trying to find the inverse, right? So the inverse of matrix A, and then I hit enter, and then it looks like this. And then you might say, oh no, it's got weird decimals, boo-hoo. So how do we change that? And I don't remember myself, so I need to go back to the calculator instructions, because this means there was calculator instructions provided by the book. And what did they do? They pressed alpha and F negative 1, and then to 4 and enter. So let's do that right now. So I'm going to press alpha, that's this green button here, and F to the negative 1, that's this y equals button, and then number 4, that converts it from fraction to decimal and so on. Enter. And now it's given me my answers as fractions. Okay, there may be times that might be useful. I'm not sure when, but anyways, so if I multiply this matrix times this matrix, we will end up with the identity matrix. And it doesn't matter if it's switched around, right? So I'm going to say, take this matrix times matrix A, right? Because I can have the inverse times matrix A, or vice versa, and we should get the identity. Let's see. Dun, da, 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 da. It is the identity. Okay. So, key things. Okay, so to find the determinant. So to find the determinant, we're going to do the A times the B minus the B times the C. Okay, and then it's denoted DET capital A, or just it looks like absolute value of A. Okay, and then if the determinant is not equal to 0, then there is an inverse, and we can find the inverse by 1 divided by the determinant is a scalar times our matrix, with it switched around with the D and the A switched and the C and the B sign changed. But if the determinant is equal to 0, then the inverse does not exist. Okay, so here I've shown calculation for finding the determinant, and I found my inverse matrix. Here the determinant is 0, so there is no inverse matrix. So you may want to make a note, even though you've got that calculator instruction page, you may want to make a note. If you hit alpha, the y equals button, and the number 4, that's going to convert from decimal to fraction, and it will convert from fraction back to decimal. Okay. The one thing is that you need to be aware of is the older calculators, the TI-83. If you look at a TI-83, this does not work. If you hit alpha y equals, it's not going to give you this option. So whenever you're taking your IB test for the HL test, make sure that you're going to use a TI-84 or newer calculator in order to get this function to convert it into fractions. Okay, so let's do example 5 here together. Solving systems. And because it's got this little picture of the calculator, the book does have calculator instructions, which I have stapled to the back of this package. Okay, but let's just do it together. Okay, so I'm going to write my matrix of coefficients, 10, -5, -3, 7. I've got my matrix of unknowns, and I've got my matrix of constants. That's what I called it, right? Yeah. Okay, so oops, right here. Matrix of coefficients, matrix of unknowns, matrix of constants. Okay, so now I'm going to take the inverse of this, and I'm just going to use the calculator to do that. So let's enter these two matrices. Oops. So first matrix is a 2 by 2, and I'm going to put in 10, -5, -3, and 7. Okay. Second mode to quit. Edit matrix B, and it's going to be a 2 by 1, and let's put in 35 and 23. Okay. So what we've learned up here, so our matrix is equal to the inverse of the matrix times our matrix of constants. So here's the inverse of this matrix times the matrix of constants. So I'm going to hit second mode to quit. I'm going to have matrix A. I'm going to hit the inverse of that times the matrix of constants, which is matrix B. Enter. And there is my answer, and we want it as a decimal, so I'm going to hit alpha. What is it? Y equals, and down to 4. Enter, enter. And now I've converted my answer into fractions. Okay, what did I do here? If they ask you to show your work and you want to see this, I can do second. I want to look at this matrix A inverse. Oops. Matrix A. Clear. Matrix A. We want to find the inverse of matrix A. Enter. And so this is the inverse of matrix A. And if you wanted to see it like this, alpha y equals down to 4. Enter, enter, and then I'm going to get this value for my inverse matrix. And I could have gotten this by calculating the determinant, 1 divided by the determinant, and then times the matrix switched around like we just did. Anyways, I'm going to let you check your work. So hit pause, try these on your own, check your work. And same process, I'm going to hit pause to check your work. Okay, I'm going to move this up. So I'm going to hit pause, and you check your work. You do all of these the same way. This is just some practice of calculating inverse matrices and more practice solving systems. Okay, so now you're going to hit pause and check your work. And lastly, you're going to hit pause and check your work. And that's it for this assignment.